So now let us draw the temperature volume diagram of water. See, you can see the y-axis you have the temperature, and in the x-axis you have the specific volume, that is total volume by mass. So let us draw the change in temperature with respect to the volume. So when the water is heated at uh, 1 atmospheric pressure. Okay. When water is heated at 1 atmosphere pressure, you can see that when you supply heat, so the pressure is kept constant. So what happens to the specific volume? See, when these molecules gain heat, these molecules volume will increase. Normally for any fluid, when you supply heat, when it gets heated, its volume will increase. You can see that, and also its temperature also initially let it be at 20 degrees Celsius. Okay, you can see that here. See, initially it is state, it is the, these are the compressed liquid state. You can see that when the temperature is increased, volume also increases, and finally it will reach a point 2, and this 2 is called the saturation temperature or the saturated liquid state, just like we have seen earlier. So all this area is the compressed liquid. Okay, then you have, okay, so what happens if you supply heat further? So just like we have seen here. So initially it was at 1 atmosphere pressure and temperature 20 degrees Celsius. Now it reaches 100 degrees Celsius and 1 atmospheric pressure. So this is the saturated liquid state. Now when you apply further heat, this liquid will gradually get converted to vapor. So that is shown here. Initially this is the saturated liquid state. You can see that temperature will not change during the phase change process, because when you supply heat, all this heat will be used to break down the molecular bonds. Okay, so temperature will not increase. So finally it will reach the state 4. Intermediate state is 3, that is a mixture of liquid plus vapor, and this state 4 is the vapor state, complete vapor state. Now from 4, if you supply further heat, temperature and volume will increase. Okay, from 2 to 4 you can see that volume will increase because liquid is getting converted to vapor. So vapor phase has got a more specific volume than the liquid phase. Okay, so now from 4, if you supply further heat, it will become superheated vapor. Okay, so that means temperature, if it is at 1 atmosphere pressure, saturation temperature is 100 degrees Celsius. So temperature rises, you can see that it reaches up to 300 degrees Celsius. This state 5 is a superheated vapor state. So this is how you draw the temperature volume diagram. You know that when you supply heat, when the temperature rises, volume also will rise. That is shown here. Okay, but now what happens, because all this heating was done at pressure is equal to 1 atmosphere pressure, what if we kept the pressure as 2 atmospheric pressure? When suppose we heated the water at 2 atmosphere pressure, so and initially, so let it be initial state here. Okay, so this is initially it was at 20 degrees Celsius and 2 atmosphere pressure. See, at higher at 2 atmosphere pressure it will have a volume less than that of this one. That's why I have shown it here. Okay, so if you supply heat, its temperature will rise. Okay, you can see that here. So it will have the saturated point somewhere here. So maybe it will at so it is not you need to look at the table. It will be at a temperature higher than 100. So let it be 107. So this will be at state this one. Then if you supply heat, uh, there will be a phase change from liquid to vapor. Okay, then it will reach here, and you can see that then you have the superheated vapor stage. So this whole thing happens at 2 atmospheric pressure. Just like this 1 atmospheric pressure heating, it is 2 atmospheric pressure heat, because here the saturation will be higher than that of the 100 degrees Celsius. If you take a different pressure, you can see like this. Okay. So you can draw like this. See, this is how you draw the TV diagram. And if you connect all these saturation point here, you can get a curve like this. See, it will have a dome shape. So this will go like this. So it will be like this. See, you can see that at this point, so these are all the phase change process here. These are the phase change processes here. But if you look at this particular point, you can see that there is no phase change operation. You can see there is no phase change operation. It will get directly converted to vapor without any phase change process. And this state is called the critical state. We will see that in detail. But this is a critical state.